All right, let's start talking about Unit 4, electrons. So a long time ago, we discovered that Bohr created this planetary model, right, where we believe electrons to live in things called energy levels. So electrons do live on energy levels, but they don't actually live on like really nice, easy rings. They live in a place called electron orbitals. So electron orbitals are locations where electrons are found, and each orbital holds 2 electrons, okay? So a way to think about this is when you hear the word orbital, you can think of it as like a type of house. So electrons live in very specific type of homes, and we give them each a different name. So let's go through the 4 different types of houses that electrons can live in. So electrons can live in an s orbital, right? Remember, when we hear the word orbital, you're going to think of the word house, right? This is like the type of house. The s orbital sort of looks like a sphere shape. Okay, and so you got to think like a circle here. Can draw a really interesting sphere there. In each energy level, you can only have one s orbital or s house. In each house, each orbital, we can fit exactly 2 electrons, so we can fit a maximum of 2. It's very low energy, okay, so we can't fit that many in there, okay? After the s orbital, we have the p orbital. The p orbital is like a bigger house, okay? So in this p orbital, it's shaped like a peanut. So in this peanut shape, you can sort of looks like an infinity symbol like that. So in this p orbital or this p house, you can fit, there are 3 bedrooms. So you can think about it like that. So when we think about how many, okay, you can think of this as like the number of bedrooms this house has. So the S house is really small. It only has 1 bedroom, and each bedroom can fit like 2 electrons. But the p orbital has 3 bedrooms. So it's a bigger house, more bedrooms. So each bedroom, okay, each orbital can fit 2 electrons. So we can fit a total of 6. We can say that this is like a medium type of energy. Okay, the next type of house or next type of orbital is the D. You can think of it as like a daisy, right? So it's sort of like a flower looking shape like this. In this d orbital, you can think of it having like 5 bedrooms. It's like a 5-bedroom house. So each bedroom can fit 2 electrons. So you have a total of 10 electrons that can fit in there. This is high energy, okay? So we're getting higher and higher and higher. The next type of house or next type of orbital there is called the f orbital. You can think of this as a really intense flower because it has a lot of stuff. It's like, it looks sort of crazy, okay, like that. In this orbital, in this house, you can have 7 bedrooms, right? 7 rooms, essentially. Each room can fit 2 electrons, so a total of 14. This is very high energy, super, super, super high, okay? So this is where you have 4 types of orbitals that electrons can live in, okay? So we are gonna learn about orbital notation. Orbital notation is a way to show where the electrons actually live in like, instead of drawing them like 3-dimensionally and sort of crazy like, we show like a really shorthand version of where the electrons are going to live. Okay, so let's talk about it right here. Okay, there are 3 rules that go with orbital notation. So that's this right here. We already wrote this word down, but I'm going to write it. So I'm going to go through the rules, and at first they're not going to make sense, but when I go through an example, then it's going to make a lot more sense. Okay, so let's just follow along. The first rule is called the Aufbau principle. Aufbau principle says that we got to start with the lowest energy, so level 1 energy, and you got to work your way up. Okay, so Aufbau means that it's German for filling up. So basically you start at level 1 and you go to level 2, level 3, level 4, 6, and then 7, okay? Rule 2 says that you have the Pauli exclusion principle. It says that each orbital, remember each like bedroom can only fit a maximum of 2 electrons, but the key word here is that they have to have opposite spins. How we draw that is opposite arrows. So there has to be one arrow going up and one arrow going down. So opposite spins means they point in opposite directions. Okay, and I'll show you more an example in just a second. The third rule is called Hund's rule, and Hund's rule is when it says you have to have 1 electron in each orbital before you double up in the same energy level. Basically what this means is that when you have electrons in the same house, okay, and you have multiple bedrooms, you want to put an electron in each bedroom before you double up. Like, would you rather have your own room or would you want to share with your brother and sister, right? You'd rather have your own room. So you got to put every electron in each room before you double up, okay? So this is like a generic picture of the periodic table. Okay, so I'm going to sort of talk about it here, and then I'm going to draw it again on your actual real periodic table. So if you look here, you always start at the lowest level. So where's the lowest level? It's this level 1 right here. This is where the lowest level is. In this lowest level, there is only one type of house, right? So I'm going to start color coding some stuff so you can clearly see it. So here, the s orbital is right here. This is where the s orbital are. So these are where the s houses are. You can think of it that way. Next are your p's. Your p orbitals are here. And then after that, you have your d orbitals that are here, right? And then your f orbitals are down here, okay? So it's sort of hard to read right here, so I'm going to re-explain it on your actual periodic table right here. So if you have your periodic table, I would color code it so you can like follow along. You don't have to go too crazy on the colors, but I would definitely follow along. So let's write some notes down here. You know that right here, this is the lowest energy level. So you have to start here. Okay, another way to think about it is electron number 1 is here, so you have to start with electron number 1, okay? So you're gonna fill the electrons in very specific homes, okay? So let's label once again where everything is. The s orbitals are here, so I'm going to border it like this, okay? So you can color it if you want to. So the s orbitals live here. So I'm going to put S here as a reminder that this is where the s orbitals are. So if an electron is in one of this green section, that means it lives in an s house, okay? So then what's the next section? The next section are your p orbitals over here. So your p orbitals, okay, is over here. That means all of the electrons that are in this orange box here, they all live in some sort of p house, okay? The next one was your d orbitals, right? So your d orbitals are right here. That means the electrons in this section all live in a d house, okay? They all live in some sort of d house. And all the elements and electrons that are down here, they live in an f orbital or f house, okay? So now let's talk about how we can know where the electrons live. So if you start with electron number 1, which is right here, okay, you ask yourself, what is the lowest energy level? So you can think of these as like a street. So on street 1, so that's our lowest energy level, where is electron number 1 going to live? Electron number 1 is going to live on the first level, first street, in an S house, because it's the smallest house, right? Because it's in the S area, okay? So it's going to live there, okay? Now, electron number 2 is here. Where does electron 2 live? Well, electron 2 still lives on energy level what? 1. It's on street 1, okay? But it still lives inside the S house because each house, right, can fit, or each bedroom in each house can fit 2 electrons. So electron 1 and electron 2 live in the same house, in the same bedroom, okay? Then let's think, where does electron 3 live? Okay, well, electron 3 can't live on street 1 because it lives on street 2. It lives on energy level 2, okay? So here we're talking about energy levels on the left-hand side, okay? So you can squeeze that in here if you would like. So energy levels are these numbers right here. Okay, so electron 3 lives on energy level 2, street 2. What house does it live in? Which section does it live in? It lives in the S house, right? Remember that each house, right, has a certain number of bedrooms, right? And for us, the S house has 1 bedroom, right? So each bedroom can hold 2 electrons, right? So over here, electron 3 and 4 both live in the 2s house. They are sleeping together in the same bedroom, okay? Then let's skip. Where is electron number 5? Electron number 5 is here, right? So electron number 5 lives where? Well, what level is electron number 5 at? Electron number 5 is still on level 2, okay? So if it's hard for you to see, you can renumber the other side. This is 1, 2, 3, 4, 5, 6. So right here you can see that electron 5 is still on level 2, street 2, but what house does it live in? Okay, it doesn't live in the S house anymore because what section is it in? It's in the orange square. If it's in the orange square, it lives in the P house. So boron, electron 5, lives in a 2p house. On street 2, there is a big P house. Now let's recall, in this P house, how many bedrooms does a P house have? It has 3. You can think of it as like 3 orbitals, right? So where do the other electrons live then? So electron 5 lives in the P house. Electron 6 lives in the P house. 7 lives in the P house. 8 lives on the P house. 9 lives in the P house, and 10 lives in the P house. So 6 electrons can live inside a P house because it has 3 bedrooms. Each one can fit 2, right? Are you starting to understand? So then where does electron number 11 live? Electron number 11, right, lives on level 3. It lives on level 3, right? But what house does electron 11 live in? It lives in the S house. It's like a small house, right? You can only fit 2 electrons in there. So both 11 and 12 live in the S house, okay? Now, if you keep going and going, then where does 13, 14, 15, 16, 17, and 18 live? Well, they all live in level 3, but they live in the big P house where there's 3 bedrooms and you can fit 2 electrons each. It gets a little complicated starting on this next one with 4. On level 4, okay, you have electron 19 and 20 live in a small, tiny S house on street 4, level 4, right? Now, the question is, where does electron 21 live? This I'm going to star because a lot of people tend to mess this up, okay? Electron 21 live in a very special place, okay? I know you're thinking 21 lives on level 4, but it's slightly complicated. It actually lives on level 3, okay? The d orbitals and the d homes actually drop 1 level down. So electron 21 actually goes back to street 3, so level 3, and lives in a really big D home, okay? In a D home, right, you have 5 bedrooms. Woo! It's like a very expensive house. You can fit 2 electrons each, so you can fit a total of 10 electrons. So where does 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 all live? They all live in the 3D house, okay? So all of them live on street 3, right? In a big D home, okay? Now, this is where people can mess up again. Where does electron 31 live? 31, you got to pay attention, lives back at level 4. See, level 4 right here. So you go back to street 4, right? So it's like on street 4 again. Okay, it lives in a P home, P house, P orbitals, right? You have like 3 bedrooms, 3 orbitals. You can fit 2 electrons each. So 31, 32, 33, 34, 35, and 36 all live in a 4P house. Okay, level 4. So street 4 inside a P house. Okay. So if you keep going, the next 2 electrons live in a 5s house. Then here it goes backwards again. So all the Ds always go backwards 1. 39 through 48 live in a 4D house. It always goes backwards 1. But then if you go back to 49 to 54, electron number 49 to 54 live at a 5P house. Okay. So let's just do a couple of examples together to like really like hone it in, okay? So remember that there are 3 rules to follow, and I'm gonna show you an example of these 3 rules while we do an example together, okay? So this is here for reference. I'll keep going back to it. So let's look at this example right here. In order to visually show orbital notation, we use a bunch of lines and arrows, okay? So let's start with the question. The question tells us to basically draw out oxygen, okay? So in order to do this, we need to know how many electrons oxygen has. So if we go back to our periodic table, oxygen is right here. It has 8 electrons. So I'm going to make a note to myself. It has 8 electrons. So if we have 8 electrons, okay, so earlier in the notes, we said we need to draw 8 arrows. Arrows represent electrons. So for every electron, we need to draw an arrow, okay? So now what does rule 1 say, right? So rule number 1, the Aufbau principle says you have to start at the lowest energy level. So basically you can think of this as like the cheapest house. So where is the cheapest house? Where is the lowest energy level? That's going to be level 1, right? So we got to start down here. So you start at the lowest level. So at street 1, we only have 1 type of house, right? So according to our periodic table, electron 1 and electron 2 both live in the same house. They live in an S house, right? We show that by drawing 2 arrows. Now, you got to draw these arrows very specifically. So you draw 1 arrow going up and another arrow going down. Why? Because in rule number 2, the Pauli exclusion principle, it says you can fit 2 electrons in each orbital, but they have to be opposite spins, okay? So opposite spins means one goes up and one goes down. So basically, you can think of each of these lines as like its own bedroom. In each bedroom, you can only fit 2 electrons. So they're like roommates, okay? So now, we drew electron 1 and we drew electron 2, right? So this is electron number 1. This is electron number 2. Well, where does the next, right, 6 go? So where does electron 3 live? So if you use a periodic table, right, electron 3 lives where? It lives on level 2, street 2, and what kind of house does it live in? It lives in the S house. So you go here, and you can fit 2 electrons here. So up, 1 down, right? So that is electron 3 and electron 4, right? So electron 3 and electron 4. Okay, we still need to get to 8 electrons. So where does electron 5, 6, 7, and 8 live? Okay, so then you got to follow the rules again. What's the next house available to us? The next house available to us, if you look here, is 2p, right? That's like the next level up. You can tell by on the periodic table, look for electron 5. Where is electron 5? Electron 5 lives on level 2, street 2. What kind of house does it live in? What kind of orbital does it live in? It lives in a p house, right? So if you look here, that's exactly where it lives. So you put electron 5 here, like this. But now let's listen to Hund's rule, okay? Hund's rule says you got to put 1 electron in each orbital before you double up. What is it saying? You need everyone to have its own bedroom before you give it a roommate, okay? You can think of this as like social distancing, right? Everybody needs to social distance before you start putting other people into each other's rooms, okay? So if I put electron 5 in this bedroom, then where would electron 6 go, okay? It can't go in this bedroom, it has to go in the next bedroom. So electron 6 goes here, okay? And we always go up, up, up before we go down, 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 okay? Then where does electron 7 live? Well, it's still in the p house, right? But it has to go in the next available bedroom, next available orbital. So this is number 7 here, okay? Then where does 8 go? Okay, so electron 8 can't go to the next level because you have to fill up the orbitals, you have to fill up the houses before you're allowed to go to the next level up. So do each bedroom have 2 electrons yet? No, so you have to fill them up. So where would electron 8 go? Electron 8 goes back to the beginning here, and you have to now give it a roommate. And now you have to force it to give it a roommate because it has nowhere else to go. So electron 8 goes here, okay? So if we were drawing it out, it would look like this. Now, this takes up a lot of space, so we tend to like redraw it. So let me just redraw it for you really quick. We draw it usually going sideways. So we'll say like the first 2 electrons live in the 1s. After that, they'll live in the 2s house. 2 electrons live here. After that, we'll say in street 2, like level 2, there's a p house. In the p house, we have 3 bedrooms, okay? Then we would write, this is electron 5, 6, 7, and 8. So if we wanted to shorthand it, we write it like that, like this, okay? Okay, so how do we shorten orbital notation so that it's easier to write and easier to like quickly write and quickly understand and look at? We can shorten it to electron configuration. So electron configuration gets rid of all the lines. We don't show the bedrooms, we don't show the orbitals, we don't show the electrons, we don't draw arrows. We just keep it nice and short and sweet, okay? So what we do is we still write the energy level, we still write what kind of orbital, what kind of house they live in, but we instead just write how many electrons live there. Okay, so let's look at the example nitrogen, so the one we just did earlier, and see how we can shorten it up. So we know that nitrogen has 7 electrons. So you know that it has to have 7 arrows originally in orbital notation. But how do we get rid of that? So in the 1s, so level 1, in the s house, we can fit exactly 2 electrons. So instead of drawing 2 arrows, we write the number 2 instead, okay? So that's what we do. So in the 2s house, we can fit a maximum of 2 electrons, 2 arrows, and so we write the 2 here. You write it like as a little superscript. That's how many can fit in there. Then what's the next level? The next level is 2p, right? So in 2p, how many electrons can fit in all of 2p? So 2p, so it's asking like how many electrons total live in the entire house? So in the entire house of 2p, right, there are 3 electrons living in that house, Okay, how you can tell that this is correct is if you count up all the superscripts, they should equal to the number of electrons of that element. So the 2 plus 2 plus 3 equals 7 electrons, then you know it's nitrogen. So for example, down here, if you count up this 2, 2, and this 4, you know it's a total of 8 electrons, and you should know that that's oxygen, right? According to the periodic table here, 8 electrons is oxygen. Okay, so all you're doing is you're still writing the level, like the street number and the type of house, type of orbital that their electrons are living in. But instead of drawing stuff, you are just simply writing how many electrons are living in that orbital, living in that house. So 1s can fit 2, right? So that's where we got this 2. 2s can fit 2, right? But 2p, so right here, we consider the entire house. In the entire house, we fit 4 electrons. And so we put a 4 for that total there. Okay,